I've been using this project in my class for about 10 years now, and I use it specifically to teach manufacturing skills, things like CAD, CAM, CNC machining, traditional wood shop work, safety, kind of the whole gamut of anything that may fit into a manufacturing setting. And there's a lot of steps in the production of something like this in a class setting. But today we're gonna start where I have my students start, and that's with the design of the body. Disclaimer, I need to put a big disclaimer piece here. I'm not a guitar builder, I'm not an instrument builder, I'm a shop teacher. I use this project to teach students manufacturing skills. I'm by no means an expert. So as I go through this, if you see something I'm doing incorrectly or something I could do better and I could teach my students better, please let me know in the comments below. So throughout the years, I've used a lot of different versions of software, but I've always rotated between three main methods or strategies to complete this phase of the project. For this first method, we're going to do a full body design using a CAD software, and I use in my classes Autodesk Fusion 360. It's a great software, and it provides a pretty straightforward and simple project for the students to learn how to use a design software. Step one of this first method is actually go to Google and find an image of a body style or whatever you want your ukulele body to look like. I usually have my students start by just typing in guitar body styles and finding one that they like. From there, we can go to our Autodesk Fusion 360, save a file before we work, so in case it crashes on us, and then start a new sketch, place it down, and draw a rectangle that's going to be the size of the body blank or the size of wood that we're going to use for our ukulele body. I usually use somewhere between 10.5 to 11 inches wide by about 12.5 inches tall. From there, we can insert a canvas or an image onto that, and we can use that rectangle to size whatever image and body style we're wanting to trace on Fusion 360. So we insert that image, we have our body style, we may have to rotate it around, and then we can size it up and position it on that rectangle so we can get it the size that we want. Once you have it positioned and sized where you want inside that rectangle, the next step is to place down a new sketch that we can use to trace around the body style. The most important piece is where that neck is going to come out of your body. For our ukuleles, we use an 1.5 inch wide neck, so you need to make sure you have yourself enough material at the top of your body to use with the neck when it's created with the CNC router. After that, you're just going to use whatever tools you would like inside your sketch panel there to trace the outline of your body. Most of the time, I like to just use a 3-point arc to trace everything around, but you could use lines, you could use splines, and you could even draw half of it and mirror it to the other side if you had a symmetrical looking guitar. As you work, you may notice portions of your sketch that don't align properly. Using some geometric constraints and just a little moving your lines around usually fixes the issue and gets you a solid looking design. It doesn't have to match perfectly to what you have as your outline, but it should look pretty close. When all is said and done, you can finish your sketch, go to your extrude command, and extrude the body profile to whatever thickness of body blank material you're using. We generally use an 1.5 inch thickness. With the bulk of the work of the body already modeled, the next step is to create the pocket where your neck will be installed. For this, you're going to place down a new sketch and just draw a rectangle on the top portion of your body where your neck is going to be installed. Draw that rectangle to the size you need. We're usually using something like a little over 1.5 inches by 2 to 3 inches tall. And then we just round off the corners to whatever the diameter of our end mill that we're going to be using with the fillet command. Generally, we're using an 1.5 inch flat end mill, so we round those corners off to 1/2 inch. Once that's finished, we can just go to our extrude command, extrude that into the depth that we need. Depending on the size of your neck blank, that's generally somewhere between 1/2 inch to about 3/4 inch. So once we've got the neck pocket on there, the next step is to add all of the pockets that we're going to need for the electronic components to turn this into electric ukulele. So all of these pieces. And when I'm using this method, I usually have my students measure their components and design their pockets and their channels individually. That way they kind of reinforces their measurement skills and has them do a little bit of problem solving as we work through this. So that works best if you have the actual components to do that, so you can match your body with whatever components you have. So you need a pickup, something that's going to be installed there to pick up the vibration of the strings, some sort of volume knob, a potentiometer, and a jack, input output jack. And then I also recommend you have whatever bridge you're gonna work with as well, so you make sure whatever pockets you have, leave enough space for that bridge to get installed somewhere. That way you're not putting your channel where you would need that bridge installed. So once you know the components and the dimensions you're gonna be using to create your pockets on your body, you can create a new sketch. And the first thing you wanna do is get the center line of your ukulele body kind of marked, because we want our pickup to kind of go in the middle of our neck. So that way all of our strings go across our pickup where needed. So I have my students just use a construction line and find the midpoint of their neck pocket and then just draw straight down. Then we use that construction line still to create a center point rectangle, and that we use as a reference point for our bridge. So that way we know how much space we need to include and don't go into the area where our bridge might be installed. From there, we can turn off our construction lines, use a center point rectangle to create the pocket where our pickup will go. That'll depend on the dimensions of the pickup that you have. Just want to make sure you leave yourself enough space between your neck pocket and that pocket that you're going to have for your pickup. The area where your jack and your volume knob are going to go will be somewhere down in the bottom right. That's generally where we put it. And the best way that we found is to use the offset command and just offset the profile of your body in. We need to offset it in by about 1/4 of an inch, so that way there's enough material there to provide structure to your ukulele body, but it's thin enough that the jack can go all the way through and we can plug in the ukulele when we're finished. The pocket that you're going to create down here to house those components is really arbitrary. It doesn't really matter what it looks like. It's all going to get covered up by a pick guard later on, so that can look however you want as long as there's enough space for those two components to work. Once you have your pickup pocket and that little pocket for your volume knob and your jack, you just need to connect those with some sort of channel so your wires can go between and you can solder it all together or install all of your components later. The biggest thing you want to make sure you keep in mind is however wide that channel needs to be is the little bit wider than whatever end mill you're going to be using. So we use a 1/2 inch end mill, so that channel has to be just a little over 1/2 inch wide. So when we program this to run on a router, the actual tooling can get in those spots. Then you can use your trim command, trim up all the open spots, maybe use the fillet command to clean it up to make it look a little cleaner. Then when you're finished, you just finish your sketch, go to your extrude command, and then you extrude it to the depth you need. And then that does it. You're finished with your ukulele body using a CAD software. So this method tends to be much faster. There's not nearly as much design skill needed from the student perspective, but it does open up the creativity my students use by like 1,000-fold with the simple method we use with the software called Aspire. So the first thing you want to do in Aspire is set up your job, which is set up in the material size that you're working with. This you'll want to have the dimensions of your body blank so we can size the design inside of that rectangle or square that'll be created after you've done your job setup. From there, you're going to import in the image that you want to turn into your ukulele body. You'll position it inside of your body blank spot there on your screen and size it and position it relatively where you need it to be cut on the router. Aspire has a great tool that allows you just to trace an image. So it's called Trace Bitmap. You activate that command. Black and white images work the best. We don't mess with many of the settings. We're just going to click preview and apply. And as long as it's a clear, nicely contrasted image, it should outline and trace that pretty well. From here, we have just a little bit of design work to do. We don't need the neck portion of that design, so we're just going to draw a line to trim off the neck portion of that image where it extends up. With the outline of the body done, we need to move on to the neck pocket. For this, we're just going to open up our rectangle command and draw a rectangle that would produce a pocket in your body that would house the neck when it is all assembled later. So you usually will make that pocket just slightly bigger than the width of your neck, and then we have our necks go into our body about 2 to 3 inches. Once you have it sized, you just need to get it positioned. The one thing you want to remember is you actually want your rectangle to be just on the outside of your body. So you can use the position command inside of Aspire to get that done. This way, when the CNC router runs the end mill around, it will completely clear out that rectangle and it won't leave any little corner bits that we need to take off later. Next up, we have to do the design work for our electronics component. The first thing we'll create is a pocket for our pickup. We want that to be aligned with our neck. So we'll use a line command, bisect that bottom edge of our neck pocket and just draw a line straight down. Open up a rectangle command and draw a rectangle that would be the size to house our pickup component later. Once you have the size you need, we can now use our line that we created to position that rectangle in the center of our neck. And for that, we can go to our position tool, highlight our line, copy the X position, click on our pickup rectangle, paste that X position in and apply it, and our rectangle is now centered along that neck. We also need to position our pickup pocket in the Y-axis. We usually try to have about a gap of 1 inch in between that pickup pocket and the neck. The next step is we need to create the pocket for our volume knob and our jack. For that, we use the offset command. We're going to select the profile of our body and offset that in a distance that would allow our jack to get through to the other side of the body. From there, you can use your design tools to create whatever shape you would like. It's pretty arbitrary as long as it's big enough to house your potentiometer and your jack when it's all machined out. Using the trim tool and the select and delete command, you should be able to clean up the rest of your design so you just have that pocket you need for your electronics equipment. From there, all we need to do is create a channel from our pickup pocket down to where our jack and our volume knob will be placed. The thing you want to remember here is we need a gap wide enough in between our channel to allow our end mill to fit. So if you're using a 1/4 inch end mill, you want that gap to be a little bigger than 1/4 of an inch. We use a 1/2 inch end mill, so we want our gap to be just a little bit bigger than 1/2 of an inch. Once you're finished with the channel, you just want to clean it up with the trim tool. The thing I love about this method is it allows my students to get really creative. They can choose any image they want and turn it into any body style they want, from guitars to shapes to animals. All right, and option 3. No student design whatsoever. It's the fastest one of all. You don't let them do any real design work. You just give them the file and then you move on to the next phase. For me, that's giving them the file so they can set up their tool paths to work on the CNC router and then work with the machine setup on that portion of the project. This moves through the initial phase of this project very, very quickly, but it does take away those skills of design and working with the software, and a lot of that creativity involved is stripped away from the students. All right, the design phase of the ukulele project is finished. I've used all 3 of those methods throughout the years, and they all have pros and cons. Currently, I'm using that method 3 where I just give the students the design file for kind of the basic Gibson style guitar, and then we jump straight into CNC programming and machine setup on our CNC router here. Thanks for watching. If you want to keep up with the ukulele build project, be sure to subscribe below and then watch this video here where we actually start building.